Hey guys, today we're going to be solving some rational and radical equations, two different types, and let's go. First one is rational, equations with fractions in them. What we're going to do with these things is we're going to multiply everything by the LCD and make the fractions disappear. So what's going to happen is basically the LCD of 3 and 2 is 6. I'm going to multiply that term by 6, that term by 6, and that term by 6. And what's going to happen is the 3 and the 6 cancel, which gives me 2. So I'm going to multiply 2 times the numerator, 2x minus 8. This 2 goes into 6 3 times, so I'm going to multiply 3 times that numerator. And, of course, 6 times 0 is just 0. So in one step, I have no more fractions. I'm just going to solve it like a normal equation. So distribute the 2, distribute the 3, and it still equals 0. If I add my x's, it's 5x. If I add the 16 and the 9, it's 25. I'm moving the 25 over, divide by 5, x is 5. That's all there is to it. So the main thing, the new thing is the first step. Multiplying everything through by the LCD and canceling out your fractions. Let's try another one. All right, this one I have x squared over x minus 3 equals 9 over x minus 3. Now the beauty of this one is the LCD is already x minus 3, and they both have it already. So I'm multiplying this side times x minus 3, this side times x minus 3, and what happens is they just cancel, so all that leaves me with is an x squared equals 9. So just take the square root of both sides, and you would get x is plus or minus 3, and check your answer. When I say check your answer, you need to check, make sure it doesn't make the denominator 0, which the positive 3 would, so the only solution would be negative 3. I forgot to tell you that on the last slide. All these problems that you need to check your solution. Matter of fact, let me show you something on this next one that will help you a little bit. All right, on this one, a little bit bigger, a little bit tougher. When you have denominators that you can factor, you need to go ahead and do that first. Like this first one, you can factor out the 3 and make it x plus 2. The x squared minus 4 is the difference of squares. It's x plus 2, x minus 2. The third one you can't do anything with. And here's what I think would help you some. What I would do when I start is go ahead and decide what x cannot equal. Like when you get done, x cannot equal negative 2 or positive 2 because that would make my denominator 0. So I'm just going to remember this right here as we get going, that my answers cannot be those two things. Now, this is a little bit tougher as far as GCF goes also. GCF is every single factor that's down there. So my GCF is actually going to be 3x plus 2, x minus 2. And I'm basically going to multiply everything, all my fractions by that to make the fractions go away. So how it works is this. This first one, the 3 times x plus 2 would cancel with that 3x plus 2 right there. So we'd just leave x minus 2 times 2. So I'm going to multiply the 2 times x minus 2. Basically, the way it works is whatever their denominator is missing from your LCD, that's what you multiply your numerator by. So like this second one, that has the x plus 2 and x minus 2, but it doesn't have the 3. So I'm going to multiply the 3 times the 1. My last one, this denominator doesn't have a 3 or the x plus 2. So I'm going to apply that times the 4. So I'm doing 4 times 3 times x plus 2 because that's what it was missing or that's what it needed, or it cancels. So either way you want to think about that, it's good. Distribute the 2. 2x minus 4. 3 times 1 is 3. That's really 12 times x and 12 times 2 on that side. So I have 2x minus 1 is 12x plus 24. I'm going to move the 2x over here, make it positive. So it's going to be 10x plus 24. Move the 24 over, will give me negative 25. Divide by 10, I'll get negative 25 over 10, which reduces, of course, to negative 5 halves, which is an okay answer because it's not one of those two. It's not negative 2 or positive 2. So we're good. All right, now we're going to move to the second part today, which is radicals. And just like we got rid of the fractions, we're also going to get rid of the radicals. And we're going to do that if it's a square root. We're just going to square both sides. So I'm going to square both sides here. If you square a square root, the square root just goes away. If you square 4, you get 16. I'm just going to move the 1 over. 16 minus 1 is 15. Divide by 3. X is 5. Check. Make sure it works. Just plug it back in. And it does. And you'll get some that don't work with the radicals. So you got to be really careful. Make sure you check your answers there. And the ones that don't work actually are called extraneous solutions, just in case you were curious about that. Same thing here. I would not square both sides unless you had a radical isolated first. What I'm going to do first here is I'm moving the 5 to the other side. So I have square root of x plus 7 equals x minus 5. This is going to be a little bit, tad bit different here because I'm going to square that side. That's no big deal. When I square this side, I got to square the whole side, not just the x, not just the 5, but the whole side. So the left-hand side, get x plus 7. The right-hand side, don't forget the pattern we do. Square the first, multiply together, double square. So square the first one, multiply together, double, and then square the second one. And because I have an x squared, I'm going to move everything over to the x squared side so I can factor it, hopefully. So if I move that x over, it gives me negative 11x. If I move this 7 over, it gives me plus 18 equals 0. And that does factor. I get x minus 9, x minus 2. So my two solutions are 9 and 2, probably. Plug them both back in, double check. If I plug 9 in, that'd be 5 plus 4, that would work. If I plug the 2 in, it'd be 5 plus 3. 2 does not work because if I plug 2 in, the right-hand side would be 5 plus the square root of 9, and the right-hand side would be 2. Square root of 9 is 3. 5 plus 3 is not 2, so 2 does not work. That's why you have to check those. And again, that's called an extraneous answer, which we'll talk about tomorrow. One more to go. And here it is, the biggest one of the whole day. Square root of x minus 3 plus square root of x plus 5 equals 4. Really stay with me here. Do not square until you get one radical isolated. So I'm going to take that radical to the other side. So I have this square root of x minus 3 equals 4 minus the square root of x plus 5. Now really, this next step is the doozy. If you can get past this next step, you got it made. I'm going to square both sides. So I'm squaring that side and this side. If I square the left, this radical just goes away, no big deal. The right-hand side, I'm going to do the pattern where you square the first one, you multiply them together and double, so I'm going 8 on x plus 5. Then I'm going to square the other radical, which is x plus 5. Now the problem with that, that's all well and good, but I still have a radical. So what I'm going to do now is I'm going to move everything over except for the radical again, and I have to square again, which is kind of a pain, but you got to do it. So first thing I'd notice, if I move the x over, there's an x on both sides, which basically means that they're going to cancel each other. So the x's are gone. Over here, that leaves me this negative 3, and I have a 21 minus 8 on the square root of x plus 5. So I'm going to move the 21 over there, which will give me a negative 24 equals a negative 8 on the square root. Now, negative 8 goes into negative 24, so I'm going to go ahead and divide both sides by negative 8, which will give me 3. And so that worked out really good. And I have a square root isolated now. So I'm going to square both sides again. Square here, square there, square everywhere. So I get x plus 5 equals 9. Move the 5 over, which gives me 4. Now, before I go crazy, like, yes, I'm finally done, you got to check. So if I put 4 in the left-hand side, way back up at the top, I'll get square root of 4 minus 3, which is 1. Square root of 4 plus 5, which is 9, equals 4. Now, the square root of 1 is 1, the square root of 9 is 3, so 1 plus 3 does equal 4, so it's good. My answer is 4, and there it is. That's the hardest one you're going to see all day tomorrow. Hopefully it wasn't too bad just watching that. If you need to go back and watch some more, do. Make sure you answered your question correctly, and I will see you tomorrow.